Welcome to Dedan Kimathi University. I am Aristide Bouyensan Nyumu, PhD engineer in energy and electromechanical engineering. And this program is project is about renewable energies. Renewable energies and compressed air energies. Here the main objective is to use compressed air energy storage to supply the renewable energy as solar and wind. It's known that solar and wind has a fluctuated character. Then to be able to introduce them in the electrical grid, we have to find a solution to make them controllable, to regulate the frequency and the voltage. Then here the first step is to compress the air. We have two stages. Then when the frequency is above the set point, it will run a motor using a drive. That is a G100 schematic. Then it will run a drive to compress the air. The second stage is when the frequency is below the set point, we'll use a motor to run a generator which will produce a power to supply the grid. Then to be able to do that, we have controllers. That is a schematic S7-1200 controllers with the analog input-output module. We have a remote system which is AT200 SP that will allow us to control the load. Then we have sensors. Those sensors will convert, that is a frequency meter. It will convert the frequency value to the analog signal 0 to 4 milliamps to the analog module. The analog module will send that, take that signal to the PID and send the desired output to the IP converter. And the IP converter will set the pressure. Then that pressure will monitor the speed, the mechanic power of the generator to provide the desired frequency. Also, we have a drive. Then the drive, this analog signal will send the analog signal to the drive, which will monitor also the motor. We have also a voltage transistor, and this voltage transistor will convert voltage value to the analog signal 4 to 20 milliamps, which is used by the controller.
I am Barnett Masenga with a background of masters in engineering, specialized in advanced manufacturing and automation. First, I will start to introduce the parts of where we get the energy from the air. We have compressor. This wire is from the compressor, and we have our filter. This is a filter of the filter and lubrication system. So during the connections, you have to make sure that the cables or pipes are very well tight or close to each part. So from the compressor to the filter, from the filter to the IP controller, IP converter. Sorry, this IP converter takes the air to the pneumatic motor. Or which you can call it air turbine. From the air turbine is coupled with a generator. So once the air turbine rotates, we rotate it all together with the generator, which will generate now the electrical energy. From the generator, we have a switch which will allow the electrical energy to pass to the transformer. Then after the transformer, we have another switch which will allow the power energy or electrical energy to go to the controllers for controlling units. Then the following is now the operation of electrical energy. How does it work to power the control units? So, yeah, you have to switch on the circuit breaker, which will enable the flow of electrical energy to the control units, which appears like as how my previous colleague explained it.
My name is Kuyangana Richard. I have a bachelor in telecommunication engineering, and also I'm certified in CMS Mechatronics System Certification Program Associate. There are control buttons such as start buttons are switch on the rods, and the stop buttons are switch off the rods. Press start 1 to switch load 1. Press start 2 to switch on load 2. Press start 3 to switch on load 3. And to switch off load 3, press stop 3. To switch off load 2, press stop 2. To switch off load 1, press stop 1. This is a different way how to operate this system. Thank you.
The PLC program has been done in TIA Portal environment, TIA Portal V17 environment. We have 3 steps in the TIA Portal PLC. Then the first step is compressed air compression stage. Then it's monitored by drive and motor. Then if I open, I have the scaling, Normax scaling, to convert that signal to real. Then to be able to operate the PID, we have a scaling. Then this scaling is send the value, the real value to the PID controller. Then we have an input to the PID, and the output is we have used output PER. Then this signal is sent to the IP converter. Then the signal of the input is regulated using a P, a proportional, integral, and a derivative. Then here we are still trying to set the parameters of PID for optimization. Then if we get optimization, the signal should be matched with the set point. We have the red color is the PID output. The green color of the signal is the process variable. Then it means that the signal from the sensor, the frequency meter or the voltmeter. The black color is the set points. Then from here we can see that the signal is stabilized around the set points. Then the parameters has been optimized. The gain, the time has been optimized. This project is called compressed air energy storage for electrical energy generation and voltage and frequency regulation process control. In short, it's compressed air energy storage process control with Scada. The experience we have made prove that compressed air energy storage can be used to improve the efficiency and the reliability of renewable energy such as solar, photovoltaic, and wind, which has a fluctuation character. The PLC program has that the controllers 1200, the controllers also can be used to control the process as IP converter. Then here we can say that we got the desired result, and we think that project can be useful for student training. It can be also useful for engineers, technicians from industries, training on Scada system, on process control. We have electrical part, how to monitor frequency and voltage. We have mechanical part, and we have a pneumatic part. Then it's also useful for students who want to do PhD research, because there is a lot of things to learn about compressed air energy storage from the tank, the thermodynamic behaviors to optimize the behavior of the system. Also, how to use sensors to make systems run as human wants it to be, and also how to operate system in telecontrol, Scada data acquisition, and also how to link different software using Cape server. Then from here, the project has been successful. There is some boundaries that can be improved in the next steps of the project, and we hope some students will be able to continue this work and make it better. Thank you.